measurement. So by the end of this lesson, students should be able to identify and measure or calculate this quantity, what's known as density. So that's what we're going to focus on in this lesson. So we talked in previous lessons about what mass is and also what volume is. Well, density really takes these two quantities and combines them together. So a way to think about it, or the definition of density is the mass per unit volume. So what does that mean? So if we take a unit or a volume, let's say we have a cube, for example, or in this case, let's say we look at this graduated cylinder. So we have a volume here and we have a volume of liquid. So what we can do is we can calculate the density of this particular volume of liquid. So calculate the density in grams per cubic centimeter. So notice here that the unit of density is taken into account the grams, it takes into account the mass part, and the cubic centimeters takes into account the volume part. So it tells us that we have 30 cubic centimeters or 30 mils of a solution that weighs 120 grams. So another way to kind of think about it is that in 30 mils of volume, we have 120 grams of mass. Okay, and that essentially is what the definition of density is. So density is equal to mass divided by volume. So or mass per volume. So if we take this specific example, the answer is going to be density is going to be equal to the mass, okay, which is 120 grams, divided by the volume, which is 30 cubic centimeters or 30 mils. So therefore, the density of this particular volume of a liquid or volume of solution is 4 grams for every cubic centimeter or every mil. So 4 grams per mil. That's the density of it. So really what density is, it's like the amount of mass that's compressed or compacted into a specific volume. So the more dense an object is, the more matter that's contained inside it. The less dense an object is, the less matter that's contained inside the volume of the object. So flotation then, so less dense materials float on top of more dense materials. Okay, so the denser material is, and if you put that sitting on a less denser material, it will sink down through it. But if you put that same material on a more dense material, it will sit on top of it or it'll float on top of it. So objects float because they are less dense than the material below, not because they're lighter. So if we look at this example here, so we can see that out of all of the objects here, they're all made up of matter. This syrup is the most dense material, okay, so it's sitting at the very bottom. So the grape then is sitting on top of that, okay, so it can't sink down through it because the syrup is more dense than the grape. Sitting on top of that then you have water. So again, water is less dense than the syrup. Okay, so if you were to take this volume here and compare it to the amount of mass that's in this volume, there would be more mass or more matter in this volume of syrup than there is in this volume of water. And then likewise then, if we look up here at the oil, for example, if you were to measure the amount of mass that's in here in comparison to the amount of mass that's in here, there will be more mass in the water than there is in the oil sitting on top of it. So the water is more dense than the oil. And then likewise then, if you were to take the cork, for example, the amount of mass that's in this volume is much less than the same volume of oil that's underneath it, so therefore it floats. So again, less dense material float on top of more dense material. So objects float because they're less dense than the material below, not because they're lighter. So the denser a material is, the lower it'll sink. So water has a density of roughly 1 gram for every cubic centimeter. So anything with a density greater than 1 gram per cubic centimeter will sink in water. So if we look at these objects here, okay, so this object here, it has a density of 0.5 grams per cubic centimeter. So this object is less dense than water, so therefore it's going to float on top of the water. Okay, this object is 0.9, so we can see again it's still it's just on the edge, on the verge. It's still less dense than the water, which is 1 gram per cubic centimeter. So therefore it's going to float. Now if we look at these objects here, so this is one, so same density, okay, so it's going to sink in the water, and then the same then with this object here. So this is it's more dense than water, so therefore it's going to sink in the water. So the denser a material is, the lower it will sink. That's a way to kind of think about it. And this can be demonstrated in relation to flotation. So if we take, for example, an egg and we put it into water, if we keep adding salt to the water, it changes the density. So what's going to happen is, so the egg, the way that it is, it's more dense than the water. So as a result of that, it sinks down through the water. But if we keep adding salt into the water, what happens is the water becomes saturated, but the water then starts to become more dense than the egg, or starts to become as dense as the egg. So what will happen then is the egg will start to float inside the water. So it is possible to add just the correct amount of salt to water to match the density of an egg, and to make it float midway as well. Okay, so that's what we can see here. So what we're doing is we're changing the density of this volume of water to match the density of the egg that we put into it, and once they match and are equal to each other, they will float. It'll float in the middle of the solution. And that's similar to what we've seen here. So, for example, when we have this matching in density, it'll float in the middle of the volume of the liquid. So to think about it is, so density then, if we look at these two objects here, so we can see, so this object here on the right hand side is more dense than this object here on the left hand side. Why is it more dense? Because if you look at both of these, we can see that we have two properties. Okay, so volume in both cases is the same. Okay, so the volume of this is equal to the volume of this. So the volume is exactly the same in both. But if we look inside this and we look at the volume, or sorry, if we look at the mass, we can see that there's more mass here, there's more matter or particles packed into this volume than there is into this volume. Okay, so the mass here is greater than the mass here. So therefore what we can say then is that the density, so let's say if we look at both density, so the density of this and the density of this, so the density of this object here on the right hand side, it's going to be more dense than this object here. And that's a way to kind of think about it. Okay, so if we were to look at the grape, if we were to look at the syrup here, okay, so the syrup is much more dense or tightly packed than, for example, the water. So if we were to look at these two objects here, that's what we can say that the grape juice is more dense, it's more tightly packed than the volume of water. The volume of water would be like this, the syrup would be like this, so therefore it's more dense. So how can we, if we want to, so basically we're looking at these two properties here. Okay, so you have mass, so basically density, which we can measure in grams per cubic centimeter, is going to be equal to mass, which is measured in grams, divided by volume, which is measured in centimeters cubed. So if we increase the mass and reduce the volume, we increase the density. If we reduce the volume and keep the mass the same, we increase the density. Okay, so if we keep the mass the same and increase the volume, the density will decrease as well. Okay, so there are some of the ways that density can be kind of modified or changed as well. So that is density, and that's how we look at calculating density.